everyone. All right, this is the first extension video for the sequences and series unit. There's going to be a few. This one is for the third example, part B, on your arithmetic sequence series day 1 notes. All right, so this is optional. Everyone is capable of doing this problem, but if you feel like in this unit you are just trying to get by, don't worry about this extension. All right, it is going to be worth some points on your test, a very small amount, but it is more important that you get other stuff solidified and understood than this extension. This is going a little above and beyond. So what we have here is we're given a series, -7 plus -4 plus -1. We learned on this first day of notes that a series is the sum of the terms in a sequence. So I have the two formulas here. This first one is to help find the nth term of a sequence. The second formula on the right is to find the sum of n terms from that sequence. It's called a series. So they're giving you a certain number of terms to add up, and that's the formula to find the sum of them. Now, the question says, if the sum, S sub n, is 210, if you add up a bunch of terms, it adds to 210, what is the value of n? How many terms did you add up? That's what it's saying. How many terms did you add? So we need to figure that out. So I'm going to erase this stuff under the left box. Let's write down what we do know. Okay, let's look at our S sub n formula. So my S sub n formula, I don't know what the n is. That's my first question. So do I know n? No, that's what I'm looking for. Do I know a sub 1? Well, actually I do. That's the first term here, -7. Do I know a sub n, the nth term? No, because I don't know what the n is. So I don't know the nth term. However, I actually do have enough information to solve this problem, even though you don't see how yet. And I want you to look at the left formula here. A sub n equals. Well, first, I know a formula here for a sub n. I don't know what a number is, but I know a way to represent it. I can represent it with this formula. That's a sub 1 plus, I like to move the d in front, d times n minus 1. So I don't know what a sub n is, but I at least know that it equals that formula. Well, what do I know about that formula? I know a sub 1 right here, right? I know this guy. So I know a sub n is -7. And I actually do know the common difference, d. I know that I'm adding 3 to get from term to term. So I know that d is 3. I still don't know n, but I at least know those two pieces of information. So I actually can represent a sub n in a little bit more specific way than just a formula. So what I'm going to do here is simplify that expression. I'm going to distribute the 3 and rewrite this as -7 plus 3n minus 3. And again, combine like terms, and I'm going to put the 3n first, 3n minus 10. I know that is a sub n right here. So I don't know a lot, but I know that. I know a sub 1 is -7, and I know I can represent a sub n as 3n plus 10, or minus 10. And that's actually a good start, because even though I don't have an exact number for a sub n, it has an n in it. It's in terms of n, and that's what I'm trying to find over here, is the nth value. So let's see how this actually helps us other than just writing a formula. So let's see. Let's start with the S sub n formula again. I'm going to write it here so we can fill in the pieces and parts as we go. All right, S sub n. I have a value for S sub n, this thing on the left here, and it's 210. So I'm going to replace that S sub n with 210. I don't know what n is, so I'm just going to write n down. I do know what a sub 1 is. Remember, that's over here. We found it. That's -7. I do know what a sub n is. Again, that's that formula we just calculated. A sub n is 3n minus 10. So I'm going to put that in for a sub n. Now, it doesn't look great, but at least it's a start. And the only thing I'm missing now is the n, and that happens to be the variable I'm looking for. So I'm on the right track. Now what I'm going to do is I'm going to have you simplify inside the parentheses here to start. So let's rewrite this as 210 equals n over 2 times 3n minus 17. Now the next thing I want you to do is we're going to solve for n. But in order to do that, I want to get rid of this fraction that's in front. Now you could distribute it, but I think that's going to make things look more complicated because we don't want to, we're going to introduce fractions that way. And we don't want to introduce anything more complicated than we have to. So my suggestion is to get rid of this 2 from the denominator here by multiplying both sides by 2. That'll make the 2 cancel off. And you'll get 420 equals n times 3n minus 17. It looks a little bit better now. I still have parentheses. I want to deal with those, so I'm going to distribute the n on the right, and I'll have 3n squared minus 17n equals 420. So what you see here is a quadratic equal to 420. You have the tools to solve this. We haven't done this in our course yet. This will actually be the next unit. But you learned this in Algebra 1. You are going to solve this quadratic by factoring. Now right now it doesn't look like a way we can factor. So what we need to do first is we need to move this 420 over to the right hand side. Put all the terms together and set the whole expression equal to 0. When you do that, I can now actually factor this expression on the right using something called the zero product law. We'll talk a little bit more about the zero product law in a couple minutes, but in order to use it, that means solve by factoring, we need to be equal to 0. So now I'm at least equal to 0. So what I'm going to do is I'm going to factor the 3n squared minus 17n minus 420. The method I'm going to use is split the middle. There's no GCF there, so I'm going to split the middle by finding what 3 times negative 420 is. And I already did that here, and it's negative 1,260. I need to find two numbers that multiply to negative 1,260 and add to negative 17. And you're probably thinking, oh my gosh, Miss Aldrich is crazy. That's a big number. I don't want to sit and do that. Well, then you don't have to do the extension. But if you want to try to get 100% on your test, you will work for it. I know you can do it. So what I want you to do is to pause the video and see if you can come up with the two numbers. Now, if it takes a lot of time, that's okay. It's okay to have to work hard for a few minutes. If you need to, start with 1. 1 and 1,260. That's what multiplies there. See if you get what you need. 2 and whatever number. 5 and something else. So go through the whole list. 3 and 4. Skip those. Go through the whole list. See what you can come up with. Now, you can take the easy way out, and you can just wait. And you know I'm going to give you the answer eventually, so you can just wait for it. Or you can pause the video and try it on your own. That's up to you. But hit pause, try to find the numbers, and then come back. All right, hopefully you tried to find your two numbers. The two numbers that you need that are going to multiply to negative 1,260 and add to negative 17 are 28 and negative 45. All right, so now what we got to do is split the middle. I'm going to leave that 0 equals, because that's technically what you're supposed to do. Remember, to split the middle, the 3n squared comes down, and the minus 420, the first and the last term come down. The middle term here gets split up with these two numbers. So I'm going to do plus 28n minus 45n. And what you're going to do is factor by grouping. So I'm going to group the first two terms together and the last two terms. The GCF for that left group is an n only. So I have n times 3n plus 28. And the GCF for my left or my right group is negative 15. Remember, I can pull out a negative GCF because that third term is negative. And you'll be left with 3n minus 28. Now to write the official factored form here, I pull the 3n minus 28, or plus 28, I'm sorry, I forgot plus here, into one group, and then I put the GCFs in the other group. Now that's factored form. How do I find what n equals? Well, that zero product law I referenced up here says that if I have two things multiplied together that equals 0, one or both of them have to equal 0. So what I can actually do with each of these is set each factor equal to 0 and solve each little mini equation for n. On this side here, if I subtract 28, I get 3n equals negative 28. So here would be my n. Okay, that's one possible solution. Here n, I just add 15 to both sides, and I get n equals 15. Two choices, which n is it, or is it both? Well, let's think. N is the term number. What number in the pattern is it? And first of all, this guy on the left, we haven't seen any negative term numbers, so that's a little concerning. Also, term numbers have to be counting numbers and integers, whole numbers. You can't have 28/3 of a number. So this guy on the left is not your solution. You could have 15 terms, so therefore you are adding up 15 terms, and that is the solution. All right, there will be a couple other videos here. You can watch them if you want to continue working on the extension problems.